Okay, let's get started. Again, sorry for the delays. I had some problems getting connected, but I'm ready. Let's go. So, as it says, I'm Niels Claeys, and today I wanted to talk to you about building a data platform and what does it take to build a data platform. Um, this is actually a follow-up of a blog post I did a couple of months ago, where I explained why I will not build my own data platform again, and which got quite some traction. And we had a feeling that a lot of people are interested in this and are wondering, should they do it themselves? Should they buy a product? Which was the start of this webinar. Um, so before diving into the content, let me tell you a bit more about myself. So I'm Niels Claeys. I've worked as a software engineer for over 9 years, and the past 5 years I mainly focused on data within the data ecosystem. I worked as a consultant, so I helped multiple customers develop their own data platform or improve it, and I learned a lot from that. And this is mainly what I want to share with you today. Mm, I'm now a developer on Conveyor, which is a product we have at Data Minded, and the goal of the product is to help customers build their own data projects. And we help them from the ID phase until running it in production, and we want that customers should only focus or should ideally only need to focus on their business problem. They shouldn't think about low-level infrastructure or cross-cutting concerns. That are things we want to handle for them, since that's something you can do in general. Solving their business problem and delivering business value, that's what they should focus on. Only one more slide on Conveyor. What sort of use cases can you run on top of Conveyor? We handle batch use cases, data warehousing use cases, but also machine learning and real-time streaming. And as mentioned, we handle a lot of the cross-cutting concerns like scheduling, cost management, security, etc., for you. And you get the additional benefit that you can get started quickly. You get a jump start, as you say, and you can start developing initial use case without needing to wait to build the platform. Conveyor runs on top of Kubernetes and currently supports both AWS and Azure clouds. So if you want to know more about the product, go to the website dataminer.com/conveyor, where you get all the information, try it out yourself, or you can contact us and then we can schedule a demo. So now let's dive into the content of this talk. I want to use a use case as a reference throughout this talk, and the use case I want to I want to use is how to build a batch ETL platform. So I'm keeping it basic. What do I need for that? Is I want functionally to be able to read from operational systems, doing some transformations and writing it to a data lake. Additionally, my requirements for my platform are also that I need to be flexible in scheduling it. Some jobs will run daily, some hourly, some monthly, and I also have dependencies between them, of course. And so this is functionally the platform I want to use as a use case. Technically, how can you solve it? Just one way is I'm going to focus mainly on AWS as cloud. We're going to use Kubernetes, and we will use Airflow and Spark as open source tools to run on top of this Kubernetes cluster and basically to fulfill the requirements that are specified. The goal is here not to advocate that this is the right setup. It's just one way to fulfill these requirements, and it's mainly used throughout this presentation to give examples, to give some anecdotes, since I know this setup very well, and it's also a very popular and often used way to start a batch ETL platform at multiple customers. So with this use case in mind, we can start on our journey. And typically when a customer starts about thinking, I want to build this kind of platform, I notice that they have the following 3 IDs. So of course, before delivering use cases, we need this platform to be in a first version, which which is ready, and they typically think it takes about 3 to 6 months to deliver this first version, and after that we can focus on delivering use cases. And I have the feeling they often see it as, well, it's mainly a technical problem that needs to be solved. You need to stitch these different components, both open source but also cloud services, together, um, and make them work well together. And they see it as purely a technical thing that needs to be solved. If they then go to act on this and to implement this kind of platform, we notice three things. Typically, the development of this platform takes a lot longer than they initially anticipated. Typically, we see between 1 and 2 years to be able to deliver on this. It's also, the initial development is just a start. Over time, the support and running of this platform, the cost of it, but also the effort spent on it, far outweighs the initial development time. And it's something you should really consider when thinking whether you should build it. It's not just development time, it's also run and support that take a large portion of the effort. And then, as I mentioned, it's not just the technical part. You don't just need to glue different components together. You should also look at your user experience. You have multiple data engineers, probably multiple data scientists working with this platform, and you should give them the best experience possible. That's something we strongly believe, and that's something I often notice that is lacking, or there is no time anymore, because at that point use cases need to be delivered and functionally the platform works already. So let's dive into these three aspects in more depth, and I can elaborate a bit further. So first part, the development effort. Based on our use case, as a stack of the technologies we will need to deliver it could be as follows. So low level, you have the cloud foundation layer. In a medium-sized organization, this is typically handled by a networking team. You get some address spaces, you get some subnets and AWS account, and with that, your data team can get started. Your data team will start with the Kubernetes cluster. We'll configure this, and on top of this cluster, we'll add some additional components. Since we're using Spark and Airflow, Airflow is open source. It has a Helm chart, which makes it very easy to install an initial version on top of Kubernetes. Running a Spark operator is, there's also an open source one, Google open source one, also has a Helm chart, which makes it also easy to get started with. And then another component I would like to mention is the cluster autoscaler. Since we're gonna have a variable load on top of our clusters, some jobs will run at midnight, others may run only once a month. It's not easy to predict the amount of nodes we will need in our cluster to handle this kind of load. And this is where the cluster autoscaler comes in. It should basically scale up new nodes if a lot of jobs are launched, but it should also scale down when the cluster is mainly idle. This is purely done for cost savings. We don't want to spend money on things that are not doing anything useful. So high level, this could be a stack you could implement, and stitching this together, getting an initial version working. I think anybody who's in this call can do this within a small amount of time. It's not, the difficulty doesn't lie into initially configuring this. The difficulty lies into getting this up and running well, making it performant, and reducing all the bottlenecks. From a user perspective, how will this platform behave? What do I need to do if I'm an engineer and I want to build a use case on top of our simple ETL platform? What should I do? First of all, of course, you need to write your source code. You can do it in Scala, you can do it in Python. Both are supported with Spark. And you will package all this together into a Docker file, into a Docker container. You can push this to a registry. And with this, This enables basically our Kubernetes cluster to run your code and to run the jobs and the functionality you need. Next to your code, of course, you need to add some configuration, which basically schedules when to run it and what to do or what to execute. So on top, you see some Airflow configurations. The details are not that important. Where we say, well, we have a DAG, we'll schedule this once a day, and there is one task which basically executes the greeter job. And it is a Spark Kubernetes operator, which is basically a plugin for using the Google open source Spark operator. And what you need to pass it is basically a configuration YAML, a CRD, as you say, which specifies how your application or Spark application should look. And you see there the image containing your source code. You specify which application it should execute, what is the entry point, which class, where is the jar file, and then some additional information concerning resources. How much memory does your application need? How many executors do you use? So depending on how much data you will process, you will add more executors, and you will probably also need more memory. So those are the things that you as a user can configure. And these both configurations files, they can't be in your container. They should be stored somewhere else, since Airflow needs to have access to it before it executes your code. So for example, let's say we store this on S3. So now you have, as a user, you write your code, you write some configuration. How do we want to test this out in a real world environment, or on dev or on test? Well, you need to make sure you publish it to an ECR registry. You need to copy your code to S3. To be able to make it useful for users, your platform should include either a CI/CD system or a command line tool to simplify this for your users. It should be just a click of a button. It should be a command they execute, and all of this should be handled for them. So with what I described now, we have a very small MVP, something that does work, that will run your Spark code, though not being really performant or not being optimal, but for an MVP, this does show the value. But as everybody probably knows, you have the Pareto principle. We have quite some functionality added for our use case, to implement our use case, but we haven't polished it yet. And the polishing part, tuning it, making sure it works performant, typically takes a lot longer than the initial MVP. So in order to illustrate this, I'm gonna give you some examples on things you will learn. It's an iterative process, so you started deploying your initial version of your platform, but now you will see iteratively, you will need to tweak certain integrations. You will learn how to use either how to integrate with your cloud provider, but also how to use your open source tools. And you will improve your platform and make it easier to use by users. So a couple of examples on integration with your cloud provider. So our initial MVP had a cluster, it could scale, but it only took care of on-demand nodes, for example. But on AWS, but also on other cloud providers, you also have spot nodes, which are a lot cheaper, 60 to 90% cheaper. So it would be very interesting to add the support for this into your platform. So creating a spot node is really easy. The only downside is that your cloud provider can reclaim that node when it needs the capacity at any time. So it could be that you have a job running on that node, but the node will be reclaimed and your job would then fail. So in order to make your Spark application resilient to this, you need to build in some additional components and then additional support. So one thing you could do, of course, is to add the node termination handler, which basically intercepts the message, because your cloud provider will send a message, well, I will reclaim this node in 2 minutes. And that component can then handle the graceful shutdown of the different applications that are running on that node. The goal of this presentation is not to go into detail on how to do this. I created a blog post a couple of weeks ago explaining how you can make your Spark application more resilient when using spot nodes. Since within Conveyor, we have quite some experience with this, since we heavily rely on spot nodes, such that our customers can benefit of the cost savings. Another thing you might want to tweak is the resources that are available for a node. By default, if you create a node, let's say it's at 16 gigs of RAM for vCPUs in your Kubernetes cluster, that doesn't mean that those resources are completely available for running jobs by your users. There is some overhead to be managed, and you have some system overhead, you have some management for management overhead, and then additionally you also have some daemon sets, some applications that are running on all your nodes, for example, to do some logging, to publish metrics, but also to configure your networking, etc. That also need resources. So the resources that are available by your users are the 16 gigs and 4 vCPUs minus the overhead. What we've noticed is that in both Azure and AWS, the default settings are working, but they're quite big. Since we know what type of workloads we run on our nodes, you could reduce this overhead quite drastically, and thus maximize the resources that are available for users. For example, if you would shave off 1.5, 2 gigs of RAM of the overhead per node, if you have 1,000 nodes, that gives you a very big improvement, or you could launch a lot more jobs on the same amount of nodes, again, reducing your costs. But these are things you will need to iterate over. It's not something you can change once. You will change some settings, you will run workloads, see how it behaves, and then gradually improve it. A last thing which is important when integrating with your cloud provider is that typically what we like is that our jobs use a least privilege role. So you give your job just the permissions it needs to do its job. We noticed that in a couple of other products that you typically have one role that is used by all the jobs that run in a given cluster. That means that if the credentials of that job would have leaked or would come into the wrong hands, the person has access to a large portion of your infrastructure. So we want to make it configurable per job which permissions it should use. And the diagram here shows a way to do this in AWS, where you basically, for a job, you can attach a role, and that role has permissions, and it basically says, well, you could read from this database, you can write to S3, and you have access to this metadata store containing the schema of the output you write. So that reduces the attack surface and makes your whole solution more secure. Next to learning how to work with your cloud provider, you also need to learn and get experienced in running your open source tooling. Since we use Spark, Spark has really a gazillion types of parameters you can tweak and you can change, which makes it very difficult as a novice user to find out what is important, which configuration to set, which is not important, and thus, as a platform team, if you would develop this kind of platform, it would be good to have a template or create some abstractions where you can bake in a lot of sensible defaults already. Examples of what we use, for example, is we have our custom log4j properties to make it less verbose and useless output, but still keep the relevant output for users. We add support for Spark decommissioning, which is basically a way for Spark to resiliently handle spot interrupts. And also we add support for the magic committer, which drastically improves the performance of your Spark application on S3. And these things we we gathered iteratively. It's researching, looking at which new features were added to Spark and how can we integrate them in the platform. So this is something you will need to do over time as well. It's not that your initial version of Spark contains everything you will need. It will evolve over time. Same thing with the autoscaler. As I mentioned, it's responsible of adding nodes, removing nodes from your cluster. It also has quite some properties to tweak. The default settings are good for a general purpose cluster, but since in this case we're using it mainly for batch processes, some of those settings are not the best in our use case. For example, we quite aggressively scale up and down when, for example, a node is not needed anymore. If you would also have long running APIs or something, that's maybe not the best approach. But if you just run batch workloads, this works as most efficiently and cost effectively. A last part is that when running Airflow on top of Kubernetes and using an Airflow scheduler, what would typically happen is that when running an Airflow executor, is that if you start your job, Airflow will create a worker pod, which is responsible for handling that job. And that worker pod, the only task it will do is basically start your Spark application. But it will not start it, it will create the YAML file I showed initially. And then the Google Spark operator will handle creating the correct pods, etc. One of the consequences of this is that if you go to the UI and you would click on the logs, the only logs you would see is the logs of the Airflow worker. It would only show, well, I created this YAML file and I registered it. It will not show you the logs of the actual code since it's not in there. So you'll need to provide a mechanism for your users to easily query the logs of their applications. They could do this by immediately going to Kubernetes, but ideally you would want to develop a UI like we did. Click of this button, it shows a portion of our own UI, which shows basically the logs and the metrics for individual applications. So these improvements are as well things you learn when people start using your platform and try to troubleshoot something. You notice, well, this does not work as expected. We need to add more support for this. Next to the learnings of integrating with your open source components, with your cloud provider, there are also many cross-cutting concerns you need to be aware of. You need to implement security, you need to have the scheduling part, scaling part, cost management, etc. I'm just going to focus on one here, and that's scaling out. And scaling out is typically seen as just a technical problem. Your infrastructure should be able to handle running 10 nodes, running 100, maybe running 1,000 nodes. You would run from 1,000 jobs a day to 100,000 to 1,000,000 jobs a day. That's a technical issue. But actually, it's also a lot more of a functional decision. How do you want to work how do you want that your teams, data engineering, data scientist team, collaborate on top of your platform? How will they work on different projects? How do they interact with each other? And one of the questions you could ask, do they all use the same Airflow environment, which makes them coupled? If something would go wrong with that environment or some team would make a mistake, that could cripple down the infrastructure for the other teams as well? Or do you want to create different Airflow environments? If you want to have dedicated environments for every team, maybe your platform should include an easy way to create a new Airflow environment. That are things you could think about. And then if they all use the same one, maybe you don't want everybody to have the same permissions. Maybe you don't want everyone to have the permission to deploy certain code to production, for example. And these are also things you need to work out and build a mechanism into your platform that make it safe for users to interact onto the same cluster. The second aspect is something that I've noticed is often overlooked, and that's actually the amount of time it takes to support this kind of platform. Over time, support on this on a data platform will the cost of it and the effort spent into it will far outweigh the initial development cost. As I typically look at a bigger organization who wants to start building their own data platform, they think of it as a project, which has a fixed start and a fixed end date. And you see it a bit in the red line. The initial version is delivered. Okay, there is some more time to do some initial fixes, doing some handovers, but then actually all the budget is gone, and we need to apply for new budget to do something specifically. While actually, if you delivered your initial version of your platform, there are a lot of tasks that are recurring, things you will need to do to make it work well, and on the long run, let's say. So let's dive in. What are these tasks that I'm talking about? Well, the one thing is bugs. Of course, any software product will have bugs. The best people to solve these are, of course, the ones who initially wrote the software. They know the ins and outs. It's most efficient if they fix them. The second part is an aspect that's often overlooked and requires quite some effort. And what am I talking about? It's you're using or you're working with a lot of open source components. You're also using quite a lot of AWS services. All of these get updates. They get new versions. You will need to have a strategy how you will incorporate these new versions into your platform. For example, if a new Airflow version comes in, what will you do? Will you wait a year, 2 years, and then do a big bang? Or will you try to keep up to date with it? And we at Data Minded and the Conveyor team as well, we strongly believe in the evergreen strategy. We try to keep up to date with the latest versions because we think that small incremental updates are a lot cheaper and easier, have far less risk than doing a big bang upgrade once a year, which updates a lot of your dependencies. And this is why we try to keep up to date with recent Kubernetes versions. We upgrade them regularly, but we also upgrade our Airflow versions and also the libraries we use in our code. The third thing, and that's of course something you can never anticipate, is you will need to do some firefighting. Things will break, things will go down, and sometimes quite badly, and you cannot plan for this. You need to have capacity, people who can jump on it. For example, a couple of months ago, we had a major outage at one of our customers because we had issues with the network file system we used for running our Airflow jobs, but also our Spark jobs. It had worked for 2 years fine without any issues. And then all of a sudden it breaks quite badly and no new jobs can be scheduled. And so at that point, you need to really have to drop everything and say, well, okay, first try to mitigate the problem, make sure jobs can again be launched, and then create a process of improvements where you want to say, well, this is how we're gonna make sure that this will never happen in the future again. And the last thing that I talk about is the typically end user support. Uh, Being in the Conveyor team, serving multiple customers, we notice that a lot of users have similar questions. We get the same questions over and over again. Typical things are, well, my Spark application goes out of memory. What should I do? Should I just increase the memory it has available, or are there other parameters I should tweak? Another typical thing, my job can't access the database. What am I doing wrong? So those are typical questions, and it would be good if you have a team that can answer those, or it's easy to collaborate on these, because once you've figured this out once, it's very easy to say, well, you just need to do this, but to figure it out the first time, sometimes it's a lot harder. So that's why we also invest quite a lot of time in end user support, and people can ask questions. And that's something within the organization you should also try to cultivate or make it easy through Slack support channels or something, that you multiple people can, or multiple teams can collaborate on solving problems. And then the last part I want to talk about, and I'm using a quote of the engineers of Airbnb here, is that you should really build in user experience from the start. It should not be something you think about when the platform is finished. It should be something you think about throughout the development, how to make it better. And that's also something we strongly believe in. So one of the things is focus on usability. Think about how your engineers, your data scientists will use your platform and make it as easy as possible for them to use it. Many engineers don't like it when you force a given product onto them. But if you make their life easier, if they see that if they use this product, certain tasks take a lot less time, then they want to use it and they become advocates, and it's a lot easier to um, get your platform used by the full company. One of the ways to do this is by providing templates or paved roads, as they say in Netflix, for standardized operations. In our case, a new ETL flow. It should be very simple for a new user. Pick this template, fill in the code he needs, and he shouldn't know all the details of how to schedule it, how to use Spark, but the default should already get him into a working state. Another aspect that is really important that we noticed is that you should make it simple for users to troubleshoot their issues. You should help them to diagnose problems with their own code at least. In that way, you can save on support, of course, but it also enables them to fix it themselves, and that makes them feel good that they can fix it themselves. Typical things here are provide the logs in an easy accessible way. What we also do is to translate certain cryptic AWS error message to something actionable, like, well, you passed in the wrong role, or your AWS role doesn't exist, instead of a cryptic message there from AWS. Additionally, what we also typically do is show spot interrupts. So if a job failed and there is no apparent reason, it could be because of a spot interrupt in certain cases. We show that immediately to users that they're not gonna try to dig out, what did I do wrong? Did I make a mistake here? No, they see it clearly, oh, it failed because of this. And that helps, and that makes their lives better and easier. Another thing that your platform should support is how you want to how you want your teams to work on it. So if you're a company who wants to um, make it possible to deploy 5-10 times a day, you should build in support in the platform that makes sure that deploying a new update of your product takes a couple of minutes and it doesn't take a couple of hours to package all the dependencies, etc. Next to the usability of the platform, your platform engineers, they should also think about how can I make these users more productive. And this is typically in a conversation with them, knowing how they work with it, the typical struggles they have. Think about new ways on making their lives easier. These are typical things that a user maybe doesn't come up with themselves, but you, with in-depth knowledge of the platform and the knowledge of how to use it, can think about. A couple of examples we have in Conveyor here, is that what you would have in when developing an ETL flow and testing things out end to end is sometimes you try to iterate um, in an actual environment. Unit test doesn't fit because certain conditions can't be met, certain data is not available in an environment. So we basically see that some users have really iteration, they change some code, they build it, deploy it, and then click start a new run of your application on that environment. To make that simpler, we just created a command that bundles all this together. And you get immediately the logs of the output shown in your console. This makes it easy to troubleshoot these kind of problems and improves the development. Another thing we believe in is throwaway airflow environments. We make it as easy as possible to create new airflow environments. It takes less than a minute. Also destroying them takes less than a minute. So that enables users to just create their custom airflow environment, test things out without impacting code or versions that are running on their dev environment already, but they can really test things out on their own before merging it into their development workflow and impacting others. And a last example is, well, typically you always want to reduce feedback cycles. What we did in Conveyor is we typically notice that a lot of users, they make mistakes in their airflow configuration. And you typically only know it when you deploy it to an airflow environment. It will say, well, you have an error here. This process takes maybe 3, 4, 5 minutes, but these issues, which are compile time issues, they can be detected quite early. So we build it in when building the product. So you do a build of your code and you immediately see, you forgot this import or you misused this function. So that were the three main topics I wanted to discuss: development effort, the effort required to support it, and working on user experience. And to finish off this presentation, I think the following quote summarizes the presentation quite well. As a company, you should understand that there is a difference between can you build a data platform and should you build it. You should build it if it is a core business. It's a key differentiator for your company, then you should build it. In other cases, it might not be the right approach. A colleague of mine had a very good analogy. I found a very good analogy related to CI/CD systems in software development. 5 to 10 years ago, when I started my engineering career, almost all companies, they managed their own Jenkins, their own CI/CD system. And they thought it's crucial for us. We have some specific requirements that nobody else has. Nowadays, almost all companies, or there are only a very small number of companies that still manage their own CI/CD because they have really special requirements. All the rest, they just pick it off the shelf. It has become commodity by GitHub Actions, Bamboo, or something. And I believe that something similar will happen with the data platforms. Maybe we haven't found the right granularity yet, but over time, I believe that people will think about it as commodity, and the actual value lies in the use cases you will deliver. So that was all I wanted to talk about. If there are any questions, please put them in the chat and I'll try to answer them. There is a question on Conveyor. Do we provide end-to-end monitoring of ETL? We have, let's answer me in two ways. So we have a whole monitoring stack to basically make sure that the necessary components are running, and that's something we monitor as a team. And if there are issues, we tackle them. Next to that, you have your own ETL flows, which you will schedule, and there you are responsible for monitoring them, but we do provide support on best practices on how you can get alerted if a certain ETL flow fails, or what to do in that case. So we know quite well how to do this, but that's not something we monitor, since that's more on the data side. But if the underlying infrastructure fails, that's something that we handle as a team and we work on. Yes. I hope that answers your question. I see a question on what budget should you foresee when implementing a data platform. Well, that's difficult to answer. It all depends on, yeah, what are the functional requirements you need? Is it a standard ETL flow? Do you have real-time use cases? I had worked at multiple medium-sized companies where the development effort was for 3 to 4 people at least a year, so you can maybe have an idea on how much work it is or how much time you spend, and maybe how much it costs. But a concrete budget I can't give you, I'm afraid. We have a question about Michiel, who's asking how your journey would be if you build a data platform and then switch to Conveyor, or you start with Conveyor and then switch to an internal data platform. Well, what we notice is that typically a lot of our customers have already tried building it themselves. So we typically see that they have gotten experience in building themselves and they have struggled with it, or they know how much effort it costs them, and then they see more the value of a tool like Conveyor, rather than users who start on their journey. It's sometimes difficult to explain how much effort it would be and what are the things you will encounter over time, that users starting on building their data platform often think that it's simple and they can do it themselves. Um, and then the larger companies who have tried that, they switch to Conveyor afterwards because they saw this cost us too much money and it's not better or it's worse than what this company provides. So we typically see a lot of companies that have experience with it switching to Conveyor. But we would like to convince as well users who are early on their journey to use Conveyor immediately, because we think that it helps them, like I said, speeding up and getting something up and running quickly. Then we have a question on how privacy and security is taken care of in Conveyor if multiple customers are using it. So, well, all the details are on the website, but to briefly explain, so we have a small portion of Conveyor which runs in our own AWS account and which is general for everyone. And this basically serves the UI, for example, and the API. And all the requests you do when you use command line, if you interact with Conveyor or the UI, they basically direct traffic from, so we decide, so you have, sorry, so if you issue a command on Conveyor, it goes to the central place, and there we decide, okay, it's for this user, so we send it to the data plane, we call it, which runs in the customer's own environment. So that means that all the workloads, what is actually running, is purely specific to one customer. It runs in their AWS account, in their Azure account, and it's not shared across different users. Okay, I see there are no more questions. Thanks a lot for listening. I hope you learned something, and have a nice day.